Good morning. In continuation to the yesterday's talk, irrigation engineering is the branch of civil engineering which deals with supply of water according to the requirement of the crops to the agricultural fields. Rainfall to a great extent helps agricultural operations, but to have the water requirements of crops to be met with, you may have to have a streamlined supply of water, and that streamlined supply of water from the source to the destination. Source is the water reservoir and the destination is the agricultural field. You have a network of water carriers, and that network of water carriers and network of the water carriers from the beginning of site selection, layout, planning, design, construction, management, monitoring, and maintenance. As you have seen the other civil engineering practices, irrigation engineering also deals with evolution of all these aspects. So, one system we are told that it is a storage system or a tank irrigation system. In a tank irrigation system, you have a big pond, water will be stored during the rainy season, during the monsoon, water will get collected, and according to the requirement of the crop, water will be sent to the agricultural land through small ponds. There will be a bigger pond, the smaller ones, then it will ultimately reach the agricultural land. Tank irrigation system. The second type of irrigation system is the direct irrigation system. Direct irrigation system is a network of water carriers such as canals, channels, pipes, like that. You may require all those things. So you collect water very water reservoir, a reservoir which is capable of accepting water from the catchment. Catchment is called the drainage, is nothing but the drainage boundary where rain water by runoff will get collected. So we will have a huge ponding and we can millions of meter cube of water can be stored. Then that will be regulated. That water will be stored, then it will be supplied, regulated to the other side. The face of the structure which imbounds water, the structure which imbounds water in the water reservoir is called a dam. When the size, the height and the width of the structure is more, it is called a dam. If the height of the structure is comparatively less, then it is called a weir. W-E-I-R, weir. Weir is a small dam. If still less, then it is called a bund. So bund will have lesser height. Weir will have little more height. Dam will be very high according to height. So this dam detains water in one phase. The dam phase detains water. One job of the dam is detaining water. Whatever water comes during rain comes as runoff and gets collected in the water reservoir, and that phase of the dam is called the upstream side. U bar S, upstream side. So the other side of the dam is called the downstream side. So if you look the side view, of the dam, this side is the upstream side and this side is the downstream side. So proper regulatory arrangements, control arrangements will be there to maintain the water level at the upstream side of the dam. Whenever a particular water level is reached, that is called the maximum water level. Maximum water level. You will give a some factor of safety or a tolerance. That is called the full reservoir level. So full reservoir level, once when the rainfall is very heavy, the reservoir will be filled and excess water will come. That water has to be drained to the downstream side. You cannot collect it. You cannot allow the water to overflow. That will create great damage to the dam as well as to the downstream, to the population and people who are in the vicinity in far-off places also. That is one of the reasons why which you, whenever you have natural calamities such as flood, water comes with a great velocity, with great quantity. The dams cannot accommodate that much quantity. So the moment you open the dam, water will be flushed out with a very great velocity and quantity to the downstream, flooding the nearby areas. Since the velocity is very high, it will uproot the trees, even buildings. So it will become a natural disaster. So control, the dam plays a very important role in detaining water, first function of the dam. Second, accumulating water. Whenever you have an obstruction, water which comes, gets accumulated, storage. So purpose of the dam, one purpose is the storage dams. It stores. So detains water, accumulates water level up to the full reservoir level or maximum water level, then maintains water. So this maintaining process is done by having gates, shutters, sluices, openings on the body of the dam. In the dam, you will have openings, shutters, pipes, sluices. So water, according to how much quantity of water you want to drain out, there will be 4 or 5 or series of shutters, steel shutters. So you will raise the shutters. If you want more, again raise the shutter. Like that you will have more shutters. Then the water level. So the purpose of the dam is to detain water, accumulate water level, and maintain water level. DAM. That's the purpose of the dam. When the water reservoir or the water basin is small comparatively, then you need not go for a dam. You can have a weir. When it is a tank, you need not go even for a weir. It can be a bunt. Bunt is nothing but an earthen bank, nominal earthen bank. Usually weirs are seen not on major reservoirs. They are seen on across the rivers. Across the rivers, you can see weirs. Another type of obstructing the water. These are all obstructing the water. It's not. To obstructing, detaining the water to accumulate the water. Another type is known as the barrage, Barrage, DAM, dam, WEIR, weir. Next is the barrage. Barrage will not have a body of the structure. It will not have a structure. It is an opening, and this opening will be covered by a shutter on the bed of the river itself. The bed of the river itself, you have a shutter. As you have the shutter on the body of the dam, here the shutter itself will act as a barrage. Sometimes you will have a small projection, some small hump. Over that hump, you will have the shutter. This is the hump, and you will have the shutter. This is the flow. So, these are the three structures which detains water flow, accumulates water, and maintain water level. All the weir, dam, and barrage. Weir also can have sluices in the body of the weir. Some weir will allow excess water to overflow by proper protection of the top of the weir. Top will be protected. It will act as an escape. Water will escape over the top of the weir. So according to the height and according to the purpose, one hydraulic structure, major hydraulic structure facilitating hydropower, electric power, hydroelectric power, irrigation, water supply, fish navigation, multi-purpose reservoir, and that is facilitated by construction of a huge dam across the river to impound large quantities of water at its upstream. The downstream is the river part. River is the downstream of the dam, and at upstream of the dam you have the water basin. According to the materials, the dams are named as earthen dam, the most primitive. Wherever the agrarian countries, in agrarian places, a lot amount of these structures will be present because agriculture needs water in plenty at regular intervals. So whenever water is more, you preserve the water, store the water, and utilize when water is at demand. So for small reservoirs, you use the locally available materials, earth, soil, and you make a bund. Again, all banks will be trapezoidal in shape. We have seen for the stability of the slope. So it will have a top width, it will have a base width with a definite height. And if it is made by earth, then it is called an earthen dam. Sometimes these earth dams will have a masonry unit at the center. Then that masonry unit will be covered by earth. And then that is called the core wall. You will have a core wall and it will be totally covered by earth. So earth dam with core wall and earth dam without core wall. Whenever the height is more and more, earthen dam will be with core wall. If the height of the dam is less, you can be happy with that. Barren, you can be happy with a virgin earthen dam. Then earthen dam with a core wall. The next type of dam is the rock fill dam. Rock fill, pebbles, huge boulders, by which you just loose. You don't interlock. You interlock. Natural interlocking of these pebbles will be there, but you don't use a binder to connect them. No binder will be used, but they will be kept in position by compacting, by higher pebbles, the interstices coming on the higher pebbles with the lower pebbles, again lower, lowest, like that. The natural interlocking by compacting the natural aggregates, usually you get it from quarries. Granite rock will be put into different pieces, they will be compacted and you get a shape which is a rock fill dam. Instead of earth, you use rock pieces. If you have lay it with a definite order in layers with binder in between, you have granite stones which are connected and bound by a cementing material, then it is called a masonry dam. So earthen dam, rock fill dam, they don't no binder will be used in these two. But in masonry dam, it will be layered, a coarse rubble masonry or a random rubble masonry. Coarse rubble means all the blocks will be regular and all the longitudinal joints you can see. It's like brickwork. Suppose you use huge boulders from the granite quarry, and if you use them and put smaller pieces, then you bind that either with the lime or cement. Those are the common binding materials. So you can construct the dam either using irregularly patterned rubbles or regularly coursed rubbles. Both are called rubble masonry dams. So earthen dam, rockfill dam, masonry dam. Then concrete dams. Most popular dams, concrete dams. A stretch of a dam can be a combination of this. Some part of the dam can be earthen, then the other part can be masonry, then the other part can be concrete. That is the gateway, the shutter part can be concrete. Abutting the concrete part with the masonry, then abutting the masonry with the earth. So because when you go to the earth part, the water depth will be less because usually the basin will be just like a cup shape. Since it is having a cup shape, at the center portion you have more height. So you need a stronger material there. Then next stronger material, then the weaker material. So a dam can be of a sole material as concrete, masonry, or rock fill or earth, or a combination of these two. That is the classification of dam according to materials. We will see tomorrow. Thank you very much. God bless.